So what does it really take to build an AI that can actually make sense of global markets? It's not about one single magical algorithm. Today, we're going to pull back the curtain and look at the blueprint of a true institutional-grade intelligence platform. Think of it as a complete operating system designed to find order in financial chaos. Let's dive in.
Okay, to really get why this kind of architecture is so important, let's start with a question that sounds simple, but is anything but. How do you predict the price of copper tomorrow? The answer isn't some single data point. It's a total avalanche of information. You're trying to find one clear signal in all of this noise. You've got mine outputs from Chile, smelter outages over in Zambia, ship-in congestion in Singapore, warehouse levels in London, new policies coming out of Indonesia, not to mention some random comment buried on page 20 of a CEO's earnings call. It is a fire hose of messy, unstructured data. So where do you even begin to build a system that can handle all that? Well, the answer isn't one giant, all-knowing AI. The real power comes from building a team of specialists, a perfectly coordinated pipeline of AI agents, where each one has a very, very specific job. Think of it like a high-tech assembly line for intelligence.
And this right here is the high-level map of that solution, the 6-agent intelligence pipeline. As you can see, it's a clear journey. It starts with raw data on the left and ends with finished, usable intelligence on the right. So let's walk through what each of these agents actually does.
The whole process kicks off right here with the source harvester. This agent is the scout. Its only job is to constantly scan more than 30 different public websites, news feeds, and exchange notices just looking for anything new. It works 24/7, fetching all the raw material for the rest of the system to work with. Next in line is the document parser, and you can think of this one as the system's translator. It takes all those messy PDFs and web pages and does something absolutely critical. It turns human language into clean, machine-readable data. It pulls out key things like the company name, the location, a potential tonnage impact, and turns all that unstructured chaos into organized information. So why is that a big deal? It means a human analyst doesn't have to spend their entire day just copying and pasting. The machine handles the grunt work so the human can do the actual thinking. After that, the entity resolver steps in. This agent is like the system's fact-checker or librarian. In the real world, a single mine might be called TFM, or Tenke Fungurume, or the CMOC cobalt asset. The resolver knows these are all just different names for the same place, and it maps them all to a single unique ID, like a digital fingerprint for every single asset. And this step is absolutely crucial. Without it, you're just amplifying noise. It's the classic garbage in, garbage out problem. And it doesn't matter how smart your later stage AI is, if the initial data is a mess. Now that we have clean, verified data, the signal engine, the real analytical brain of the pipeline, can get to work. It takes all these individual events and computes predictive scores across what are called signal families. You can almost think of these as a credit score for the market, measuring things like physical supply tightness, stress in the logistics chain, or policy risk. This is the exact moment where raw facts get transformed into a forward-looking signal. Scores and numbers are great for machines, right? But we humans, we need a story. And that's the job of the narrative writer. It translates all that complex signal data into plain English summaries. It automatically generates briefs that sound just like an analyst wrote them, saying something like, "Copper markets tightened today, and it was mainly because of X, Y, and Z." And finally, we have the publisher. This agent is the delivery service. It takes the stories and dashboards that the other agents created and makes sure they get to the right people at the right time. That can mean pushing a live update to a private dashboard, sending a daily brief over email, or posting a summary to a public website. It's the final mile. Okay, so that's the theory. Let's make this a little more concrete. We're going to follow one single piece of news as it travels through this entire pipeline, and you'll see how it transforms from a simple press release into something you can actually use. Okay, look at this. On the left, you've got a single sentence buried deep inside some PDF. But on the right, after the document parser has done its job, we have perfectly structured data. The AI has correctly identified the mine, the country, the commodity, and even the estimated supply impact. This is that first critical step, turning unstructured words into a clean, organized database entry. And now look at the entity resolver in action. On the left, we have 3 different names that all refer to the same exact asset. A lesser system would create 3 separate, confusing events. But on the right, our system has resolved them into one single, clean record, all tied to that one unique ID. This isn't just a minor cleanup. It's fundamental to getting any kind of accurate analysis done. But here's the thing. As powerful as that agent pipeline is, it's still only one piece of a much, much larger puzzle. To operate at a truly institutional level, you need a complete operating system that does way more than just generate signals. So let's zoom out and look at the full architecture. This is the whole shebang. That signal engine we've been talking about is just one component, or one plane, in a system made of 10 integrated parts. And together, they form a complete operating system for investment, covering everything from the initial research all the way through to risk management, trade execution, and compliance. The pipeline finds the opportunity. The rest of the system manages it from start to finish. And believe me, these other planes are just as critical. The risk plane is the ultimate safeguard. It can block trades, and there's even a manual kill switch for emergencies. The execution plane intelligently routes trades across different venues to find the best possible price. The compliance plane maintains a permanent, unchangeable audit trail of every single action taken. And the reporting plane uses that same narrative AI to generate investor updates, which are then checked by a human for quality. It's a whole system of checks and balances built for serious, institutional-level rigor.
But maybe the most powerful part of this entire architecture is its ability to learn. This isn't some static system that you just set and forget. It's designed from the ground up to get better and better over time.
This diagram shows what we call the alpha life cycle, which is really the engine for self-improvement. Now, alpha is just industry jargon for a real, measurable edge in the market, the ability to consistently outperform. And you'll notice the circular flow here. It's a continuous, automated loop. A system without this loop might give you some insight, which is nice. But a system with this loop is designed to generate true alpha.
So let's break it down. It's pretty simple, really. The system takes in data to create a signal. That signal then informs a trading decision. Then, the system meticulously measures the outcome of that trade. Did we make money, lose money, and why? That outcome becomes actionable feedback, which is then used to automatically update the original model. The system literally learns from its own successes and failures, getting rid of weak signals and promoting strong ones. It gets smarter with every single trade.
So when you put all of this together, the agent pipeline, the complete operating system, and that self-improving loop, a really clear picture starts to emerge. The real competitive advantage isn't found in any one single piece.
The edge comes from the architecture itself. As a quote from the source material puts it, the real alpha is in the data ontology and signal engineering. Simply put, the data ontology is just the master rulebook for how all information is structured and connected. It's the intelligent blueprint for the data itself, and it's the painstaking, systematic work of building out that blueprint that turns thousands of weak, noisy signals into a clear, compounding advantage. So the ultimate question isn't just can an AI predict the market, it's have you built the right architecture to allow it to learn?